Okay, good evening. Welcome to
MathForKids number 103.
MathForKids number 103. I thought you were going to jump into my face.
Mm-hmm.
Today we spent, I don't know, what do we do, about 5 videos on binary counting?
Yep.
Today we're going to look at a little bit different number system. So in binary, we have numbers like this, 1, 1, 0, 1. We put that 2, that base 2, to remind us that we're in binary. And in base 2, the digits are, this is the ones digit, this is the
twos,
this is the
fours,
and this is the eighths digit.
And then
It keeps going up by powers of 2, right? So this number, 1101 base 2, is really what number in base 10 that we're used to saying?
It's really 13.
Right, this is really 13. Because it's 8 times 1, plus 4 times 1, plus 2 times 0, plus 1 times 1. Now, the same number system applies in base 10, right? And this is what you're just more used to. So if I have a number like, I don't know, 7,284, this is the ones digit, this is the tens digit, this is the hundreds digit, and this is the
thousands, and that keeps going.
Thousands. So we keep going up by powers of 10. So this number in base 10, 7,284, is really what number that we're used to seeing?
7,284.
Very good. Very good. Okay. So today we're going to learn about a different base that's very common for people to use in computers. And it's hexadecimal. And it'd be hard to guess what another common base that people uses, but this is base 16. And it's called hexadecimal. Okay? Now, base 16 has a little bit of a weird problem. Do you know what it is?
There's only 9 numbers.
How many numbers are there?
There's only 9 digits.
How many?
10.
10. Yeah, why are there 10?
Because of 0.
Because of the 0. So remember, in base 2 we can only use zeros and ones. In base 10 we use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In base 16 we're going to need something to represent the digits 0 all the way up to the digit 15.
We can do symbols.
So for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's really no problem because we may as well just use 2 to mean
2.
And 8 to mean
8.
Yeah, it'd be silly to use 8 to mean 1. Okay, that might get a little confusing. But we need numbers for 10, 11, 12, 13, 14, and 15. Right?
Yeah.
So we just use letters A, B, C, D, E, and F. Mean the numbers 10, 11, 12, 13, 14, and 15. Okay, now does that make sense? Is that reasonably easy to remember?
Yeah, it's pretty easy to remember.
Okay, so let's take a look. I'm not sure I wrote this in the best place. I probably should have written it off to the side. But you know what I'll do? Because it's pretty easy to remember what the numbers stand for. I'm just going to write it up here. A, B, C, D, E, F. 10, 11, 12, 13, 14, and 15. Okay?
Yeah.
All right, so first thing, let's just look at a number. How about the number 2A4 in base 16? What is this number? Well,
this is the ones.
This is the ones digit, so that's nice and easy.
This is the 16.
This is the 16's digit, and what digit is this going to be over here?
256.
Okay, and how did you get 256?
It's 16 squared.
16 squared, very good. 16 squared, which is 256. This is the 256 digit. So this number, 2A4 in base 16, is what number in base 10?
What's 2 times 256?
2 times 256.
Plus 10 times 16.
Okay, wait, you're going too fast. How did you get 10 times 16?
Because A equals 10.
A is 10. 10 times 16 plus
4 times 1.
4 times 1. Okay, good. Okay, what is 2 times 256?
512.
512. 10 times 160?
160.
160.
Number
4
six-
times 1?
4.
4. So we have to add 512 plus 160 plus 4. And what does that equal?
This is 676.
676. Very good. So base 16 is just like base 10 and base 2. You just have to know what each digit represents, and then you also have to remember that the letters represent the numbers. So we can talk about the number A, and we can talk about the number C.
Yeah.
You okay?
Yeah.
What's on your mind?
Nothing.
Nothing? Okay.
Hexadecimal.
Hexadecimals on your mind? Okay, and we can talk about the number F.
Yeah.
Okay. Now, let's do one. Do you want to do one more practice, or do you want to just jump right into addition?
Let's jump right into addition.
Jump right into addition. Why practice? Okay. So, let's do... Sorry, the green is not erasing super well. Let's stick with our number 2A4, base 16. And how about 39D, base 16, and we're going to add these together. But before we do that, let's convert these into base 10, just so we can double check it in. 2A4 we already did. That was what, 676?
Mhm.
Is that what that
I
was?
thought that was 512. No.
2A4?
Yeah, that was 676.
676. Okay, now we got to do 39D. Now just remember that this is the ones digit, this is the 16s digit, and this is the 256. So what number is 39D in base 16?
3 times 256.
Okay, so we're not doing the addition just quite yet. We're just figuring out this number. So it's 3 times 256 plus...
Plus 16 times 9.
Okay, well, I'm going to say 9 times 16.
Okay. And
9 times
D
16
times 1.
plus D times 1. And what is D?
D is 13.
13 times 1. Okay, so 2A4 is 676 in base 10. And here's what 39D is in base 10. So we just have to figure this out. 3 times 256. Well, that's 200. Ugh.
600.
How about 600 plus 150 plus 18, right?
Yeah. Which is 768.
768. 9 times 16. What's that?
It's 144.
How'd you figure that out?
It's the same as 12 squared. Which is
How'd you figure?
90 plus 54.
90 plus 54. Okay. So this is 144. The other way you could have said is 10 times 16 is 160, and then we subtracted 16. And 13 times 1. Go.
13.
Very good. Okay, so we got to add 768 plus 144 plus 13. And that's going to give us...
925.
925. Okay,
That's
very
the
good.
base 10 stuff.
925. Base 10. Okay, so this is how we're going to check our answer at the end. If we've done it right, we have 676 base 10 plus 925 base 10. That's easy to add up. Let's do that later, though.
Okay, I've already figured out what it is, though.
Okay, that's fine, but we're going to do it in base 16 first. Okay, so
Okay.
we do 4 plus D base 16. What is that?
That's 4 plus 13,
Which is?
which is 17, but
Okay, 17 base 16. I'm just going to write out 17. That's going to be in the ones column. A plus 9 is what?
it's 10 plus 9, which is 19.
19. And then 2 plus 3 is?
It's 5.
5. Okay. Now, this is a bit of a problem. What's the problem?
The problem is we have these 17s and 19s that can't be there.
Right, you have 17s and 19s that can't be there. So we have to figure out what to do with the 17. So this is 17 times 1. You remember what we did in binary when we added just two things together and we got a 2?
We made it 1 on the next one over.
Okay, you made it 1 on the next one over. What are we going to do with this 17?
We're going to make it a 16 here.
Okay, we can make this a 16 plus a 1. Okay? And that turns the 17 into a 1. And it adds a 16 over here. So here we have 19 16s. So how many 16s do we have now?
20 times.
20 16s. Okay, so is 521 our answer?
No.
No, why not?
Because there's the 20 is 16 plus 4, so we get...
Okay, so 20 is 16 plus 4. Okay?
Yeah.
And so this 20 becomes a 4. And our 16 gets added on over here to the 5.
Which becomes a 6.
To become a 6. Okay, so we get 641 base 16. Now, is that an acceptable answer in base 16?
Yes, it is.
Yes, okay. So let's just check and see. So remember, this is the 1's digit, the 16's digit, and the 256 digit. All right? So we have 6 times 256 plus 4, times 16 plus 1. Okay? All right, a little tricky to figure out, but we can do this. 6 times 256. Well, 6 times 200 is?
1,200.
1,200. 6 times 50 is?
It's 300.
300. And 6 times 6 is?
36.
36.
1536.
This is 1536. 4 times 16 is?
64.
Okay, how did you figure that out?
It's 40 plus 24.
Okay, so this is 64. Okay, now for the tricky part. What is 1?
1.
Very good. Okay, so we just have to do 1536 plus 64 plus 1.
Which is 1601. Yeah.
Okay, so our number here is 641 base 16 is equal to 1601 base 10. Now, hold on one second. We need to do an independent check of this. We said this was the same as 676 plus 925. Okay, we're hoping we get 1601. If we do, we don't have to reshoot the whole movie. So,
yeah.
I hope we do. So, 600 plus 900 is?
It's 1,500.
1,500. 70 plus 20 is?
It's 90.
90. 6 plus 5 is?
11.
11.
Yay!
Which is 1,590 11. Which is the same as?
1601.
1601.
Yay!
Yay! Whoa! It's a hexadecimal miracle. Okay, so this is
good.
This is actually pretty neat. It's a little cumbersome to start doing the first time. I mean, this is we've done it once before, but it's a little cumbersome to figure out. But once you start doing it, you can really get the hang of it. It's just like binary, or it's just like base 10. When you get a number in your digit that you can't have, you have to split it up and move part of it over to the next one, right?
Yes.
Just like binary, just like base 10. Okay?
Yep.
Is that pretty neat?
Yeah.
All right, high five.
What
do you want to do for your video tomorrow?
Maybe we could do hexadecimal subtraction.
Okay. We'll give it a go. Then we're going to have minus A's floating around. Hexadecimal subtraction. Sounds good to me.